we proceed with Earth geometry. So I remember previously we did how to calculate the distance when points are on the same latitude. Remember a line that runs from the west to the east, this is called the line of latitude. So a point can be here and a point can be there. How do we find the distance between this point and that point? Let's say this is A, this is B. We looked at the formula that we are using. D is equal to theta over 360 times 2 pi r times cos x. And I believe I explained everything. I talked about the r is the radius of, on the earth. So in kilometers it is 6,370. Then in nautical miles it is 3,487. Alright. Then cos x, x is simply on the latitude that's there. 2 points aligned. Let's say for example this is 50 degrees north. So my x will be the 50 degrees here. That's the one I'll put there. Then my theta, I also explained how you need to find the difference in longitude. Okay, so let's say here I have 40 degrees east, there I have 60 degrees west. So to find theta, I need to find the difference in the longitude. So the longitude that A is lying on and the longitude that B is lying on, I need to find the difference there. Then I talked about how we need to add the 60 plus 40 to find the difference in longitude if A is on the west and B is on the east. So if the 2 points are lying in different hemispheres, one is on the west, the other one on the east, then we calculate their difference in longitude by adding the 2 longitudes. Okay. Now we want to advance. Okay. What if What if you are told to find the distance of points on the same longitude? What do? You are told to find the distance of points on the same longitude. What are we going to do there? What we need to do is to find the latitude on which that point is lying. So obviously this point will pass on a certain latitude will pass on that point. Then this one also a certain latitude will pass there. Alright, so to find the difference in latitude, what do? We check if this is north and this is south, there is plus there. If this is north and this is north, you subtract. Okay? Again, if this is south and this is south, you subtract. North, south, add, south, subtract, then north also subtract to find the difference in latitudes. Okay? Let's dive into the example here. Alright, so they've said find the difference in longitude between points R and Q. So between the points R and Q, so you can see R is on this longitude here, which is saying 30 degrees east. Then Q is on this longitude here, saying 80 degrees east. So how do we find the difference in longitude between points lying in the same hemisphere? This is east, this is east. So we are going to say this will give us 80 degrees minus 30 degrees. And the difference in longitude between points R and Q will just give us 50 degrees. Okay, that's the difference in longitude. Then they've said calculate the distance PQ in kilometers. Okay, remember, so whenever they ask for the distance in kilometers, where there is R, put 6,370. If they want the distance in nautical miles, where there is R, put 3,437. Now, what formula do we use to calculate distance, okay, of points lying on the same longitude? You can see this P here and Q is here. So P and Q, they are there. They are on the same longitude, which is 80 degrees east. How am I going to calculate the distance of these 2 points lying on the same longitude? The formula we use is distance is equal to theta over 360 times 2 pi r. So theta over 360 times 2 pi r. What has happened here? We have simply removed times cos x. Okay? So to find the distance between points lying on the same longitude, the only thing you do is to remove the cos x and the rest becomes your formula. So how do we get theta? if the 2 points are lying on the same longitude, to get your theta, you need to check on which latitude point Q and on which latitude is point P. So theta here is found by finding the difference in latitude if the 2 points are lying on the same longitude. So how do we do it? You see, this is south, this is what? North. So these are two different hemispheres. So what do? We are going to add to find theta. So I'm going to say 20 plus 40, this will give me 60. So my angle theta there is 60. Okay. Alright, so my angle theta I'm finding it to be 60. Okay, let's proceed. So remember, for points lying on the same longitude, to find angle theta, you need to find the difference now in the latitude in which the 2 points are lying. Okay, but if we were finding for points lying on the same latitude, this straight line here, on the same latitude here, we have to find the difference in what? Longitude of the 2 points. Okay, so here we proceed. What is our theta? We are saying that our theta is 60 divided by 360 times 2 times 3.142 times r. So pi r will always be given. The only thing that you need to find is the theta. Okay, so what is our r? Our r is 63.70 because they want the distance in kilometers. So I'll say d is equal to, so I'll use my calculator and multiply 60 times 2 times 3.142 times 6370. Alright, then I said divided by 360. Alright, so this is what I'm getting. I'm getting 671.51333. So this is my distance. The distance between the points, calculate the distance PQ. Alright, of course in the exam they want you to write this in 3 significant figures, and like I said, I'll teach you that on another day. So what you simply do here is you check, you start counting from here. This is 1, 2, 3. So all these numbers here are significant. Then you check this number there. Is it above 5? If it's not, then you just replace it with 0. So you put 0 there, then I put my kilometers. Then these numbers this side after the decimal point, you just scrap them off as they are irrelevant. So that's how we calculate the distance PQ. This PQ is lying on the same longitude, so all you need to do is remove times cos x. We go to the last part of the question. Find the length of the circle of latitude 40 degrees south in kilometers. Okay, find the length of the circle of latitude 40 degrees south in kilometers. So they want us to find the length of this latitude line here. So how do you find length? Okay, so the formula for length is equal to 2 pi r times cos x. So this is the formula when they ask for the length of the circle of latitude. Okay, length is equal to 2 pi r times cos x. What have we done? We've just removed this 60. We've removed theta over 360. So we start now checking. Alright, what? So 2 times our pi is 3.142. Then our radius is 6370. They've said in kilometers, so we are using the same radius. Then times cos x. It is the one that is given in the question. So they've said 40 degrees south, so we're just getting 40 degrees. So times cos 40. Then you say my length will be equal to, on your calculator, 2 times 3.142 times 6370 times cos 40. Alright, and I'm getting my answer to be 30,664. So 30,664.0543. Alright, how do we find the length or the distance of the circle of latitude? This is our formula. The only thing that you need to know is what is my x. Your x will be there to be indicated. Okay, so you just get the number that is there. If they put 20 degrees north, I was going to use 20 there. Since they put 40, I'm using 40. Okay, then once you multiply on the calculator, this is your answer, but remember we need to leave this to 3 significant figures. So 1, 2, 3, these numbers are significant. This is greater than 5, so I'll say 3, 0. Then since this is greater than 5, it will add the 1 to 6, and 6 will become 7. Then these two numbers before the decimal point, they will become zeros. Then after the decimal point, we scrap them off and we put our units of kilometers like that. Let me run through here again. So how did we find the distance PQ? You first had to find the difference in latitude, okay? So the opposite applies. For the one that we did where we were working out distance of points on the same latitude, we were finding the difference in what? Longitude. So if 2 points are on the same latitude, you need to find the difference in longitude. Then if 2 points are on the same longitude, you need to find the difference in latitude. I think I talked about how you find the differences. If they're in the same hemispheres, subtract, different hemispheres, add. Okay, just like that.